free body diagrams doesn't mean to say they cost no money. It means that, you know, they're free to move. Okay, there's a girl standing. Gravity pulling the girl down to the centre of the earth. Okay, there's the gravity. Contact force between the floor and the girl. Okay, this is the one that gets no marks, because you don't draw a girl as, you know, like a girl, but what you draw it is as her centre of mass. We do that because then we can draw several things, like 20 or 30, all on one diagram without it getting a mess. So we just do her as a point, okay? The forces always come out from the centre of her mass. Contact force, the reaction going up, the centre of gravity being a point, a dot. The weight is the same as the reaction. Yes, so it's the same length, it's the same width, the arrow. Arrows, same length and width, because the forces of weight and reaction are equal. If forces are not equal, she would accelerate upwards or downwards. Forces emanate from the centre of gravity. Draw a free body diagram of a ladder against a wall. Ladder against a wall. Okay, this is the way to get no marks. Lots of people think, oh, okay, so the ladder's there, so therefore there's a pushing force in that direction. The ladder's there, therefore there's two forces pushing here. Well, you know, wrong, because two forces. Forces are vertical or horizontal. Yeah, we always put the forces as vertical or horizontal. We put them into components. So even if a force is pushing like that way, like if you've got a box on a slope, we change them. That's a slope, okay? That's a slope, there's a box. We change them into the vertical force and the horizontal force. This would be the reaction in those two dimensions. That way we can make them all equal and find out how big they are. An angly force is no use, so we need to know what the angle is and put it into its bits. You know, there's R, which makes the two. There's the horizontal force, there's the vertical force, they're at right angles. So this is broken apart into those two, and you need to know the angles. That's why they tell you the angle of the slope. Oh, when you draw slopes, don't draw them like that where they're about 45 degrees, because then it's difficult to get all the other angles. Draw them like that where they're about 20 degrees. Then when you make the reaction triangle, hold on, can I do this? This has got to be a right angle, yes. And yes, so the starting force makes two smaller forces, and the two smaller forces make a right angle. Okay, so if this was the 40 degrees, so notice I've drawn it like a 20 degree, okay? Ooh, can't see the 4. Okay, so when we're looking at this triangle, we can see very quickly that that's the 40 degrees. If you draw it like this, then that triangle, all the angles look the same. So I always draw this angle as very small, regardless of what the question says. Get all the marks. Friction opposes the movement as the ladder tries to slip down the wall. Oh yes, so the ladder's trying to go down the wall. That's the movement direction, so that's the friction. This is the movement direction, so the friction would be in that direction. Yeah, friction always opposes. Friction opposes movement as the ladder tries to slip down the wall and along the floor. This diagram shows friction making the ladder slip. Well, that's silly. Forces pointing left, not balanced by forces pointing right. Yeah, this diagram has loads of left, no right. That would mean the ladder would just go whoo. So that's not true. If the ladder is not moving, or the forces must be balanced, if it's not accelerating, that is. Okay, yeah, if you've got a rocket in space going at constant speed, the forces are balanced. This is a ladder, it's not moving. Forces pointing left, not balanced by forces pointing right. So the ladder would move left. Cool. Okay, that's the way to do it wrong. That's the way to do it right. Okay, so the ladder wants to move down. The ladder wants to move once. Okay, Gary, don't say once. The ladder is going to move down. If it starts moving, the ladder, that bit of the ladder is going to go down. If it starts moving, that bit of the ladder is going to go that way. So that's why the friction are in the direction opposing the movement. The reaction forces are at 90 degrees, right angles, 90-degree right angles to the wall and the floor. The weight is going down here. Now you can see that F1 plus R1 equals W. R1 equals F2. Much, much easier. Now you're doing it. R1 and R2 are the reaction forces, also called normal forces, also called contact forces, due to the atoms being squashed together. Yes, this wall atoms are squashing together with the ladder atoms, and so therefore the atoms are being squashed together, so that there's the electrons are being squashed together, so there's electromagnetic negative against negative repulsion happening there. That's what the reaction force is. And there as well, these bottom ladder atoms are being pushed into the floor level atoms. The atoms are being squashed together, making the electrons getting closer than they would otherwise be, giving you the reaction force. That's where reaction force is. F2 is the friction force stopping the bottom of the ladder sliding out. F1 is the friction force stopping the ladder sliding down. Force down equals force up. W equals F1 plus R2. Force right equals force left. F2 equals R1. F2 is the friction force stopping the ladder bottom from slipping left. Weight arrow length equals W equals the same as, because W equals R1 plus, no, R2 plus F1. Okay. Down forces equals up forces. How much force there is indicated by the length of an arrow. Forces are usually horizontal or vertical. If an object is at rest, the up forces equals the down forces and the left equals the right. Forces. Draw a free body diagram of a stationary mass on a slope on the back of this sheet. Oh, okay, this is for my book, so draw it down below, put it in the comments, I'll give it ticks and mark it for you. Right, the up equals down, the right equals left. Formula for the mass on a slope. Good! Press like, press subscribe, get my other A-levels and IB videos. There's my card. After school, I go to mid-levels to do home tutoring, GCSE, IBs, HSCs, A-levels, SATs, or I do Skype lessons for people who live outside of mid-levels or outside of Hong Kong. Yeah, some of my students are in England, some in America. My email, if your mum or your dad want me to help with your science or maths, then my email is goodluckgaryhk@gmail.com. Bye!